Unit 1, Lesson 3, Expanded Form and Scientific Notation. This lesson has two parts, the expanded form first, then scientific notation. So let's start with the first one, expanded form. How can we transfer the following number from standard form to expanded form? To answer this question, we need to change a little bit the way of writing of this number. It's written with a way that it's very hard for us to read it. So we need to write this number in group of 3 digits. So let's start from the last one, 434, 434. Then we leave a small space and we take the other group of 3 digits, 469, 469, and after that we leave small space and we get the rest. So 1 and 3. Why we are doing that? Why we leave space here? And why we group this digit in group of 3? The reason is very simple. We need to know that the numbers, it's created with this way, that the first 3 numbers we call that under the category of ones. After that it's gonna change to another category, which is the thousands, and after that it's gonna change to the category of millions. That's why I'm leaving space, and that's why there is 3 digits under each category. These digits, we need to know it, that the first one from the right is the 1, the second one is a 10, and the third one is the 100. And again we repeat, under the category of thousands we have 1, 10, and 100, and under the category of millions we have the ones, then the tens, and the hundreds. This is how we can distribute this number under this column. So let's start from the beginning, 434, 434, then 469, 469, then 13, then 13. Now it's easy for us to read this number. I have what? The first 3, it's under the 10, so we cannot see 3, it's 30. So 31 million. Then I go to the second one. This is 964. If I have this only under 110 and 1s, I'm going to read it 964. So I continue. 964 what? Thousands. Then after that 434. So the whole number I'm going to read it with this way. 31,964,434. Now, how can I answer the question? I need to write this number from the standard form to expanded form. So I'm going to repeat again. I have this number 31,964,434 equal. I know that this one, it's 3 under the 10, that means 30 million. So 30 million. And actually the easiest way that you take the first number and transfer everything to zeros. Plus, I have this one now. I can do 1 million and the rest gonna be 0, so 1 million. And again you will see that I'm trying to respect the space here, to leave the space and to make it group of 3 digits, because we understand now how we can read easily if we do it with this way. Plus, I see the 9 under 100,000, so 900,000, that means 900,000. And again, all you have to do, you take the number and you transfer anything else to zeros. Plus, I have 6, 6, 1, 6, 10, that means 60,000, 60,000. Plus, I have 4, 4, 1, that means 4,000 only, 4,000. And again, I'm trying to respect the space. Plus, I have 400, 400, easy now, plus I have 310, that means 30, plus I have only 4 1, that means 4. This is how we can write in expanded form. Someone will say, okay, I see it with another way. Why we don't multiply by power of 10? That means the first one is 3 times how many? I have here 6 zeros and 7. That means 10 million. 1, 2, 3, 1, 2, 3. And they put this in bracket to see that it together. Plus 1 times how many? I have 1 million, so 1 million. We are trying to multiply by power of 10. Plus 9 multiplied by what? I have 100,000, 100,000. Plus 6 multiplied by what? 10,000. So 6 times 10,000. Plus 4 multiplied by 1,000. 4 multiplied by 1,000. Plus I have 4 times 100. Excellent. Plus 3 times 10. Plus 4. And I will tell you now, 4 here, if we want to say I want to multiply by 10, actually, because 4 it's not multiplied by 10 here, it's like 4 times 1, the 10 exponent 0 replace the 1, and there is a lesson when we will get to the exponent. I'm going to show you how 10 exponent 0 equal to 1. So let's continue now. Now, to make it easier, instead of writing all this number of zeros, we can do mistakes. Why we don't choose the exponent? So I can write it as 3 times 10 exponent, as you can see, 7 0. So 7 plus 1 times 10 exponent, how many 0? 6, plus 9 times 10 exponent, how many 0? 5, plus 6 times 10 exponent, as you can see, 4 0, so exponent 4, plus 4 times 10 exponent 3, because there is 3 zeros, plus 4 times 10 exponent 2, because it's 100, plus 3 multiplied by 10 exponent 1, plus the last one, 4 times 10 exponent 0. And this is how we can transfer the number from standard form to expanded form. So this is the first part of our lesson. Let's see the second part of our lesson, which is the scientific notation. Scientific notation. Very important to understand the definition. If we understand the definition, it's very easy to transfer any number to scientific notation. A number expressed in scientific notation is written as product of two factors. The word product means multiplication of two factors. What the two factors? The first factor is a number greater than or equal to 1 and less than 10. That means 1 is acceptable. After that I can say 1.1, 1.2, till I reach not the 10, 9, maybe 0.999, because it's saying less. So this is my range from 1 or greater till less than 10. 10 is not acceptable. That means what? That means I need a number from this range as a first factor. The second factor is the power of 10. So something multiplied, because we said product, by 10 exponent anything here. So let's understand this in details with one example. Example 61. 61, it's not in scientific notation. I need to transfer. And when we transfer to scientific notation, don't forget, at the end it has a value of 61. I cannot change the value. So 61. 61, as you can see, it's more than 10. We need a number that it's between 1 to 10. So 6 6.1 is the best choice. 6 is greater than 1 and it's less than 10. Times. I need to transfer 6.1 to 61 because I cannot change the value. So I need to multiply it by 10 exponent. That means I need to move this decimal point one step to make it 61. That means 10 exponent 1. So again, 6.1 times 10 exponent 1 is equal to 61, and in the meantime is written under the form of the scientific notation. Now let's go to this number. It's 4 digit, 7,205. It's better to write it as 7, leave some space, 205. It's better to understand it this way. Now the first thing that I want to transfer it to a number that is between 1 and 10. So 7.205. I cannot neglect these numbers. I have to add it. Times. I need to time it by 10 exponent something to go 1, 2, 3 step to the right to make it at 7,205. That means 3 step to the right. That means 10 exponent 3. So the right scientific notation is 7.205 times 10 exponent 3. This is the right shape of scientific notation. Next, I have this number. Again, the best thing to transfer this number to a way that I can read it. So we said group of 3. That means 81, leave space, 057. How to read this one? It's 81,057. Excellent. Now I need to transfer this number to a number that it's in the range of 1 to 10. That means 8.1057. I don't miss any number. Times. I need to multiply by 10, but at the end I need to move this decimal point how many steps to the right? to 3, 4. That means exponent 4. So I can write 8.1057 times 10 exponent 4 is the scientific notation. Now I have something strange. I have a small number 0.00056. How can I transfer this to a scientific notation? As you can see, I need to focus with this number. This one is 5.6 is the number that it has between the range of 1 to 10. Excellent. But 5.6 is greater than 0.0056. That means we are changing the value. I need to go back to this value. That means I need to move this decimal point to the left how many steps? I need from here, if the decimal is here, so 1, 2, 3, 4. I need to move this decimal point 4, but this time to the left. Very important, not to the right. That means I'm gonna multiply by 10 exponent negative 4. And you will get in details more explanation about the negative exponent in secondary. You will understand that this is like a division. When we go to the left, we need to make it as negative 4, not positive 4. So the scientific notation is 5.6 times 10 exponent negative 4. Someone will tell me, I need to understand why we have to learn the scientific notation. The reason of scientific notation is going to make our life easier when we are reading any scientific book, and I will give an example to understand better why scientific notation is important. Let's say you are reading that the diameter of the insect cells is, and this number 0. How many 0? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 7. So this is a real example that the diameter of the insect cell is this amount. So If I'm reading this number, I have to focus many times, and maybe I have to repeat again many times how to read this number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, I don't know how to understand it. But it's better to say this number, it's exactly like 1.7 times 10 exponent negative, because it's very small. I need to switch the point from here to here, so I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Done. So I can say it's 1.7 times 10 exponent negative 11. This is the diameter of the insect cell. Instead of writing all this number, as you can see, it's long, now it's shorter. Easy to read it than this one, because you can mix people and the reader can do mistakes. If this number is written in small textbook, he can do mistake, but this is easier. I know that 1.7 and negative 11, very small number. So this is an example why it's important to use a scientific notation, and you will learn the negative exponent in secondary, you will understand it better, but this is how we transfer a number from standard form to scientific notation. I hope that you understood this lesson, and see you in the next lesson, Unit 1, Lesson 4. Thank you.